Okay, guys, so here is the question that I assigned. This is about a robot launcher that's firing a projectile, which is trying to hit the target. So, one of the recommendations I would make is that when you read through the problem, it kind of seems like there's a lot going on here and it can be difficult to interpret. So, it takes a skill to read through the questions and pretty quickly, like figure out what's going on. So all of these letters here just mean that we are just giving we're not giving real numbers here. We're just saying that, oh, there's a height of h. We have m, which is the mass of the projectile. V naught, so that's the velocity, and then d would be the distance that it goes. And then we got those here. We have the points. All right, so it says that you come to this setup, you're able to adjust h, you have the initial velocity being fired, and you're trying to hit a 4-point target, which is at d, this distance. So I'll let you guys like read that, but note that it is something that you want to be able to read those fairly quickly. Okay, so the first question here. So it says on the axis below, sketch the graphs. And so we're going to sketch the graphs and look at what's on the graph. We have v sub x and v sub y. So we're only looking at the components, the part of the velocity that is in these directions. In the y direction, up and down, and left and right. So let's think about this. One of the things that we learned or that we stated was that if you have let's say you have an object going in the x direction, and I can draw that, let me draw that up here. So when this object is moving, this cannonball, that no matter where it's at on its path, it's moving the same speed in that x direction. It doesn't change. Like that's if we give that, and really I should have drawn it the same length as this velocity here. So you see how all these arrows are the same, meaning that it stays, like if this velocity was 20 meters a second, it stays 20 meters a second in that x direction. But in the y direction, it changes. In the y direction, it changes from, here, it doesn't have any velocity in the y direction, but then it's getting bigger and bigger in the negative direction. Just think about it. As it falls, the velocity, it picks up velocity in that direction. All right, so let's come down here and graph that. All right, so the easiest one is to say the x direction. Well, in the x direction, the velocity is not changing. It stays the same. So whatever that velocity was, the initial velocity in the x, it stays that velocity as time goes on. And then the vertical component, remember we said that it starts off as 0, but as time goes on, it's picking up speed in the y direction, but in that negative direction. So just for example, if we gave this values here, and I'm not going to actually put these values on because for the AP test, you never want to add additional things just in case you get it wrong. So but if I were to do it, think about it. Like after like 1 second, I may be moving like, let's say, -1 meter a second, and then after 2 seconds, like I'm moving -2 meters a second. So as time goes on in the y direction, I just keep on picking up speed in that negative direction. All right, let's just make sure I got everything here. Yeah, okay, so then that's all we need. So the x direction is not changing. The y direction, it picks up speed. And note here that the slope is 0. This is just an extra thing, but the slope is equal to 0 for the x direction. That means acceleration is 0. But here, the slope is equal to, and the value would end up being -10 because the slope is the acceleration, which is gravity, which remember is -10 meters a second squared. All right, but they don't ask us for that, all that information, so I'm not going to put it. I'm just going to keep it nice and simple. All right, so scoring some points, like that's the name of the game. So we have those points. So let's go down here and look at the next part. All right. So now when the students arrive, they find out that because of a malfunction, our height is going to be stuck at h/2. However, we can launch it at the original speed or 2 times the original speed. So those are our options in a paragraph length response that can have diagrams or equations. Describe the speed at which a sphere should be launched so that the students earn the maximum number of points in the competition. All right, so let's just look up at the diagram. So it's saying that they come and this is stuck over h/2. So that means that if this is stuck over h/2, let's make a statement here. So if you have h/2, well, one of the key things that we're going to be thinking about here is like what happens to the time. So, I'm going to make some bullet points here. So, what happens to time? So we can start off like, all right, well, if the height is half of it, what is going to be the time? And the answer to that, and I don't have to be super specific to score this point. I can say that the time is less. And if you're writing a paragraph length response, I would put the time is less, and I could put a statement like in free fall or while it's in the air or something like that. So the time is less. This is actually 1 point. So remember, the name of the game is scoring points. You only have to score a handful to pass this question. And that's a pretty straightforward answer, right? Oh, the time is less. So if the time is less, then let's say like what happens then? So let's do what happens to d, the distance it travels, if the time is less, if like t is less, and we keep, let's say like we keep v the same. All right, so what happens to d if t is less and you keep v the same? And remember, that's like the initial velocity. And you might like be able to like just picture this, but d is going to decrease. So in that, what happens to that? Well, d decreases. So therefore, you're not hitting, like you're not going to hit the 4-point zone anymore. Like you can't hit it because decreases, or d decreases. So that's actually 1 point. So again, like we're scoring points here, and we haven't gotten, we've just gotten some basic statements down. Okay, so now the next points are a little bit harder. So now if you like, let's see, where should we go from here? So now the question is, I'm just gonna like, this is just gonna be written quickly. So what happens to D if like we know t decreases, But now you fire at 2v0. Okay, now here's where, so it's like, what happens if you fire twice as fast? And this is where people will kind of make an assumption and usually get this one wrong, where you might think that that oh, it goes half a d, or I'm sorry, that if d decreases, or if time decreases, and you fire at 2v0, some people might think that, oh, well, you still hit the 4 points. And let me scroll up and let's just talk about this real quick. So what I'm saying here is that some people might think that that if h becomes h over 2, but you double the velocity, well, then you half one, but you double the other. Some people might think that you would actually come over here and you would hit the target. That like doubling this one and halving this one would cancel each other off, and um, you would hit the target. But that's actually not the case. And let me show you. So this is not the case. You would not hit the 4 point. And the reason for that, and I'm going to write it, let's write it up here. And remember, now we're scoring the harder points, so don't get too discouraged if you didn't get this point. But I'm going to write up one of my kinematic equations. So the kinematic equation that I'm going to write up is this. All right. So there's the kinematic equation, and we'll work with this like so that you can understand, and like if you haven't quite mastered the kinematic equations, that's fine. So here it is. Now we're talking about in the y direction. So note that the velocity in the y direction, it started off at 0. So I can ignore that. I'm going to do a little bit of manipulation here and solve for my time. And so you can see here that when I solve for time, it's just a little bit of algebra, that I get this. So that's the time in the air. So this delta y here, well, we were talking about it in terms of h. So we got to be able to like be very like pretty good with our variables and switch things out. So I'm just going to rewrite this in terms of h. So instead of that delta y, I'm just going to put an h there. And think about this now. If I if I put a h over 2, so if I half this, does that half this? And the answer is no, it doesn't, because it's under that square root. So we got that square root. That just messes things up. So that means that you can half the height, but that doesn't half the time. So that lots of people don't score this one. So what you would have to do is say that with a little math that that if you go 2v0, that you are still not hitting the 4 points. You don't hit the 4 points. But what you do hit is you would hit somewhere around the 3 points. So you would hit, so with 2v0, you hit 3 points. All right, now, so that's the next, like to know that it hits the 3 points, that's a little bit trickier. And I will talk about that really quickly. But just note that you could have scored one of these points here just by saying that it doesn't hit the 4 points. So there's actually a point here that you could score that just says no matter what, like, and this is just like a quick statement, but some kind of statement that says no matter what, you will not hit 4 points. You could get a point for scoring that. So right there, like, let's just say out of these, I think I forget how many points are our like total here, but we're looking at like right there, if you can score these 3 points and then the 2 from above, you're at 5 points. You're doing really well if you score those 5 points. All right, so you guys that want to pick up every single point, I'm going to do this last calculation here for you. So if you actually want to find out how far it goes, I would need to know like in the x direction. Remember, velocity is this, delta x over t. Now, in our case here, like we're instead of delta x, we're talking about d. So I'm going to rewrite that. V is equal to d over t. All right, so let's solve this for d. So d is equal to v times t. So nothing too hard here, right? This is just like in the x direction. I got no acceleration, so I just I'm just coming down to this statement here. And from that algebra that we did before, I would have 2h over g, and that h, sorry, so that's h over 2, so I would get something like that. Oops, it signed off on me. So let me go here. Let me just rewrite that real quick. So we got d is equal to v times t, which is equal to v times the square root of 2, and we'll do the original equation here, over g. But now what is d when you actually do the like if you were to do 1/2 h and 2v0, then the equation would just be a little bit different. It would be d is equal to 2v0 over 2g, and then we got our h over 2. Right, so there's the equation. So if you're going for those last points, you would actually just have to come down here and figure out what d would be, and you would find out that it's that 3 point, like you would hit the 3 point. Okay, so that was really quick, and I know that like this was a hard question. So maybe you're gonna go back and watch this video a little bit more in detail, and maybe think of a question to ask me, and we can talk about that. So whatever you struggled with, and just note that if it's the algebra that you struggled with, hopefully you should feel a little better, because you could see that there were a few points there, like a handful of points that you could have scored with no algebra at all, just logicking, like using some logic to go through that. So but of course, like the AP test offers challenges. So that just means that for you guys that and girls that are up for mastering that algebra, then you have that opportunity to get that 5. So all right, take notes on, or like go through and watch this video, and I'm sure that there's like little questions that have popped up. So take notes on that and write down whatever your question would be, and we can talk about it in class. All right, hope that helps.